our YouTube channel CIT Innovation, where innovation means imagination. Today I will demonstrate a new project that is solar powered power bank for our home appliances. Last night during a storm, the power went out again and complete darkness. My phone is at 2% charge. No fan, no light, no phone battery is almost dead. And this is not just for my problem. It happens to thousands of people during this summer period. So I decide to build something simple and easy during this summer season. So our project is a solar power bank that energizes its energy from the solar panel during sunlight and saves you at night from the dark. So before exploring or before introducing our project, introducing myself, I am Souvik Poddar, a student of Camden Institute of Engineering and Technology, Budbud campus. So without wasting no more time, introducing the project. Introducing our project, that is a solar power bank. It is the full basic model or the prototyping model that I have built up. It is a container through which the whole system is processed. I just open the container. And now see, it is the total power bank. Here we used 3.7 volt battery and 24 pieces that are connected in parallel. So that's for why the voltage is 3.7 volt, but each of the cell, that is the 12 volt. Now it is a power bank of 12 volt, 7200 megahertz. And now the whole system is energized through our solar panel. It is our solar panel that which I have used here. Now see, it is the powered. Now just discuss about its power rating. It's the pickup power is 0.3 watt hour. Output current voltage is 10.8 volt. That is, it is just effective for 12 volt power supply or 12 volt battery power bank supply. Now just discussing about when I here discuss about it is the BMS model which I have used for the battery management system during, so that it can protect the system from the short circuit and the over voltage. This whole process is energized through the solar panel. If I directly connect this panel here, and now during the when the sunlight is falling on that, you see that the red light is indicated. That means the battery is charged through the solar panel. Now, what is this MOSFETs? What is the type of this MOSFET? Because in the presence of this MOSFET is used for the solar charge controller. Here we use such a 4 MOSFET, that is IRZ44N N-channel MOSFET, that represents that during the solar charge, when energize the battery, that can protects the battery from overcharging and also protects the overall system. Now why this power bank saves you from the night during I just click on here and you see there is a display module which is now 00. When I press it, now the voltage battery voltage is 11.3 volt. Now I connect a load of 3.7 volt battery. You see and see that the fan is moving, and you can give you a cool air. And now just remove the load is again 0.0. Now the lighting system which I explained here, I just click on the switch and it gives you a daylight light through which you can save from night the whole darkness. Here we used the battery bank through which the whole system is powered. Here we use booster module, so that's for why if in case any high voltage is required, that can also powering you. In this whole system we can also use power bank circuit, so that's for why it can also charges your mobile phone also. You have to place any power bank module that can be 2.4 ampere hour 5 volt module or another one. For your convenient, I have placed one power bank module which I have used later during which we have to charge our mobile phone. It is a power bank module which can provide the output of 2.4 ampere that can provide you fast charging for your mobile phone. Now I am discussing about how the battery is charged through this solar panel. It is the solar panel which I have used here. For just convenient, when I bring the flashlight light, it's then the red light is indicated that it is charged through solar panel. Now here the display module is placed, which I have placed here. Display module, it is now showing 18 volt and 00 ampere. And this regulator, through this regulator I can easily change the output voltage. Now the output voltage is 16.6, and again I press, it is 12.1, 12.1 volt, and when I am again converting this, it is 10.7, and it is 11 point and 22 point. According to best, I can easily change the output voltage, and it can be measured through this voltmeter up to 35.2 voltage is maximum. But for this charging this battery, we have only required 19 volt. That is, so we can easily set the voltage into 19 volt. 19 volts, so can the over voltage is not provide. Only we can provide 19 volt. We are setting the voltage through the voltmeter. It is 18.8, 18.1, and it is the 19.9 and 19.1 volt. And now I require one external unit for charging our circuit. And it is a male to male connector. When I connect this, I connect this section. Now this red light is glowing. That means this battery is charged through whole the solar energy. And here the booster module is present, because of why we can easily convert this generated of 12 volt through the solar panel into 35 volt. That is our requirement. So I am telling about what is compactness we have developed. It is the compactness through which the whole system is done. Here the controller, here the battery unit, and but through this system we does not operate any AC appliances. Now what is the purpose of now? We have to use any inverter circuit that can be 800 MVA or 120 watt, 120 watt, 1000 watt, etc. For next video we are introducing our any inverter kit through which the whole how any AC appliances is connected through which. And now I am again telling about the what is its lighting power. Just click on the switch, and now it's provides the intensity, that the how is its lighting power, which I have shown to you. This is enough for during the blackout at night. It is enough for your lighting in your home. It is enough. So that's for it is all. Thank you for watching our video. Thank you.